Okay, so we're going to start off this problem, which is a combination circuit, and the goal of this problem, or the goal of completing this problem, is to be able to give individual values for every resistor for your voltage, your amps, and your resistance. Obviously, you can see that the resistance is already there, but we're going to go through the process of calculating all of that up to equivalent resistance and then breaking that back down. Also, you can see here that we have our voltage, which is listed for the entire circuit, and that will play into coming up with the total amperage for the circuit at the very about halfway through this problem. So, to start off with, what we're going to do is we're going to work this as a series circuit. We're going to go R2, R5, and R8. And we're going to combine all of them using series rules, which is adding up our resistances. So we'll end up with 12. And I'm going to go down here and show you my redrawn circuit. All right, you can see here that I have R2, 5, and 8 put together, offering 12 ohms of resistance. Now we come over here to R4 and R6. R4 and R6 are also in series, so we're going to go ahead and add those together. So we're going to add the 5 ohms and the 7 ohms, and we're going to end up with 12 ohms. And come down here. All right, so now looking at this, we have R4 and 6 together. We have R2, 5, and 8 together, both showing equivalent resistances. And they both equal up to 12. Well, since they both equal up to 12, all we have to do is cut that in half, or take 12 and divide it by 2, since there are 2 resistors here, and we're going to end up with 6 for an equivalent resistor for that. So let me just move that paper up a little bit. Go. All right, so now we have our equivalent resistance for 2, 4, 5, 6, and 8 all together. And looking here, we have these. R1 and R7, and this makes another complete, or not a complete, it makes another series circuit. So we'll take our 6 plus our 14 plus our 4, which is going to end up with 24. Come over here to our redrawn circuit. All right, so position that a little better. Okay, so here's our redrawn circuit. Our redrawn circuit has all of the resistors 1, 2, 4, 5, 6, 7, and 8 together with a resistance of 24. And then we also have our 3 over here with a resistance of 12. Remember, we still have our volts over here for the entire circuit, which we're going to use here in just a moment. So now what we do is we use parallel rules for these. Okay, and how I would do this is I would take 12 times 24, which I believe is 288, and then that's the product, and then I have the sum, which is 12 plus 24, which is 26 or 36, and divide those together, or divide those, and I will end up with a total resistance for the circuit of 8 ohms. So looking at this, this one resistor is pretty much equal to the total of the entire circuit, since there's only one resistor. So we've got here our 1 through 8, or resistors 1 through 8. The voltage drop across 1 through 8 is a total of 60 volts, and we had our total of, resistance here, which was 8 ohms. We've got our 8 ohms here. And then all we have to do is we have to take our total voltage, which we knew, our resistance, which we came up with, and using Ohm's law, we just divide our voltage by our resistance, and we come up with our amperage, which is 7.5 amps. So at that point, we've come up with the totals for the circuit for all of our items, for our voltage, for our amperage, and for our resistance. Now we have to go back through the circuit and actually apply all of this. And this is where I think a lot of people get stuck, because they get to the point to where they don't really know where to go next. And so what I'll do is I will walk everybody through it. Okay, so we have this same circuit that we worked on just a few moments ago. Get that positioned how I wanted it. Okay, so you can see here exactly what we were looking at just a moment ago. So now what we're going to do is I'm going to move this paper, and we're going to talk about how we come up with the other numbers, or the individual numbers for this. So looking at this, we have to break this back down. So we come back and we separate out R3 because that was the last resistor we added to this resistor chain. Using what we have as parallel rules, because these are parallel, we're going to take our volts from this one, okay? So we've got our 60 volts from all the resistors grouped up together, and using parallel rules stating that voltage remains the same in a parallel circuit, we apply 60 volts to each of these. We already had our resistance here, so then all we have to do is divide the voltage by the resistance, and we get our amperage number, or our amps. So this one equals out to 2.5, this one equals out to 5. So that's kind of the start of how you do this, or it is the start of how you do this. So now, just flip that over like that. We're going to start from the bottom of the page and work up this next time around. All right, so looking at this one, we just came up with all the values for R3, and I keep these in here throughout the entire chain just to make sure that if I need to double check that it's right there, and also honestly it keeps me in line because I'll go through it and get confused. So the next thing to do is to separate out R1, R7, and R7 from the big group of resistors, and now that's only R2, 4, 5, 6, and 8. So in this one, we would actually use our series rules for this one. So because on, put this down here, on this last sheet, these were parallel, okay? And we had, remember, we had 60 volts, 2.5 amps. And let me cover that real quick. We have 2.5 amps. So whenever we come to this one, we have 2.5 amps that is going to be inserted from that last one into these three because these three are all series. So, and in series, the amperage stays the same. So we carried that 2.5 amps in, all right? And then all we have to do is we take our resistance and we times that by the amperage and we come up with the volts because the volts is what we would be missing. So R2, 4, 5, 6, and 8 comes up with 15 volts. R1 comes up with 35 volts. And R7 equals 10 volts. So jumping up here, you can see we moved our values for R1, R7, and R3 here. We separate out R4 and R6 from R2, 5, and 8. All right, because these are parallel rules, let me see here. Yep, because they're parallel rules, the voltage stays the same. So what you end up with, and mind you, I pulled the voltage from right here. We've got 15, and you can see that I've moved 15 up here and 15 up here because these are parallel and voltage stays the same. All right, from there, I divided 15 by 12, and I divided 15 by 12, and we each get 1.25. All right, so next, we move up here, and I leave 2, 5, and 8 alone, but I separate out R4 and R6. So I carried 1.25 over because these are in series, and then all I did was take my resistance times my amperage, came up with my voltage, so I've got 8.75 and 6.25. And then finally, I turn my attention back to R2, 5, and 8. So I separate out R2, 5, and 8, and I bring that 1.25 amps up here into these, and then I go ahead and take my resistance times my amperage, and I get my voltage. And because these all have the same resistance, and they have the same the same amperage, they're all going to have the same resistance. So they all have 5 volts, 1.25 amps, and 4 ohms of resistance. So I hope that kind of helps break it down as far as how to solve that specific combination circuit, but that you also get the idea of how you're supposed to look at these circuits visually, break them down, and then build them back up in order to come up with all of the necessary values.